In an audacious announcement, researchers have stated that they've uncovered a planet unlike any other we've seen before. Prior to NASA's fame for its groundbreaking discoveries, it has disclosed that this planet is fascinating for more reasons than just its location and size, but also because of its emission of light that appears to be artificial. Could we be on the brink of uncovering hidden truths that might drastically alter our comprehension of the cosmos? Could this discovery point toward the possibility of life on other worlds? By delving into NASA's groundbreaking discoveries, we may soon uncover the truth about this astonishing phenomenon. In 2007, NASA, with the launch of the Dawn spacecraft, set a goal of exploring some of the most fascinating things in our solar system. Fitted with 3 ion engines, Dawn embarked on a journey beginning with a 14-month study of Vesta. Dawn is the second-largest asteroid in the belt. It transmitted back highly detailed images and data, shedding light on Vesta's intricate surface and varied geological history. Following the completion of its mission at Vesta, Dawn proceeded to the second phase of its journey, one that was likely even more exciting, an extensive investigation into the dwarf planet Ceres. Dawn's ion engines allowed it to escape Vesta's sphere of influence and head toward Ceres, a feat that would have been unattainable using conventional chemical propulsion systems. These engines generated constant thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. In 1801, an Italian astronomer, Giuseppe Piazzi, made the discovery. Ceres is the largest object in the asteroid belt, located between Mars and Jupiter. For 4 years, it was considered to be the tiniest dwarf planet in the solar system, until its reclassification in 2006. With a diameter of approximately 950 kilometers, it serves as the largest and most massive body in the asteroid belt. One of the most captivating features of Ceres is its unique attributes. Scientists eagerly awaited the first close-up images of this enigmatic planet, which revealed brilliant spots scattered across its surface, particularly in a large crater known for its striking appearance. These spots sparked immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution shots taken by the Hubble Space Telescope. Very little was known about this tiny planet, but detailed observations from Dawn stoked the curiosity of astronomers and fans of space travel alike. The mission aimed to enhance our understanding of the formation of the solar system and examine the role of water in the evolution of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be made of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the possibility of volcanic activity, specifically cryovolcanism, that erupts water or brine instead of molten rock. But what exactly are these mysterious lights, and what do they reveal concerning the true nature of Ceres? Could they indicate ongoing geological processes, or something even more extraordinary? Ceres stands out from other objects in the asteroid belt due to its size, mass, composition, and the potential presence of water and ice. In contrast to the usual rocky asteroids, Ceres has a composition more like that of a comet, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began orbiting Ceres in early 2015, marking a significant milestone. It was ready to provide the first comprehensive views of the largest body in the asteroid belt. As Dawn neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The first pictures showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious bright spots amid the dark, rugged terrain. As the image resolution improved, scientists began to formulate theories about the nature of these spots. Were they areas of ice reflecting sunlight? Or could they be something even more remarkable? Speculation ranged from mineral deposits to possible signs of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't a single feature but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This suggested that Ceres had, or possibly still has, some form of geological activity capable of pushing water or brine to the surface, where it rapidly evaporates, leaving behind bright, reflective residues. These findings challenged previous ideas about Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The possibility of subsurface water or brine pockets could have significant implications for our understanding of the potential for life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are mostly made of rock and metal, Ceres stands out for its distinct composition. Its surface is a blend of water, ice, and hydrated minerals, including carbonates and clays, giving it a less dense structure than its rocky neighbors. This composition suggests that Ceres may contain substantial amounts of water beneath its surface. Its outer layer is rocky but porous, with trapped ice and various volatiles that make it resemble a comet more than a typical asteroid. It is believed that Ceres has a unique internal structure consisting of a rocky mantle and a core rich in water ice, which accounts for roughly half of the total volume of the planet. The mantle is probably a mixture of brine and rock, surrounding a denser core possibly made of silicates. The presence of substantial amounts of water ice raises the possibility that Ceres may have once supported liquid water, especially if its core was heated by radioactive decay in its early years. This internal composition sets Ceres apart from neighboring asteroids and opens up fascinating questions regarding its geological activity and the role of water in shaping its development. But that's not all. Ceres' discovery of ammonia clays suggests that this dwarf planet may have originated in the cooler regions of the solar system before migrating inward. The presence of ammonia could lower water's freezing point, making it possible for surface brines to exist. These revelations about Ceres' history and composition not only expand our understanding of this intriguing dwarf planet, but also provide valuable insights into the processes governing the formation and evolution of icy bodies across the solar system. Cryovolcanism is an intriguing and comparatively uncommon geological process, especially in comparison to Earth's volcanic activity. Unlike traditional volcanoes that expel molten rock, cryovolcanoes, also called ice volcanoes, release materials such as water, methane, or ammonia. These substances can persist in gas or liquid form in extremely cold environments where cryovolcanic activity occurs. On Ceres, cryovolcanoes allow salty water to rise to the surface. When this briny water comes into contact with the vacuum of space, it quickly evaporates, turning from solid or liquid into gas. This process leaves behind glowing, reflective residues. This phenomenon of glowing spots, thought to be salt deposits, continues to intrigue scientists. Their presence not only indicates recent geological activity but also reinforces the idea that Ceres is not a dead, dormant world. Instead, it may be one of the more active and chemically rich bodies in the asteroid belt. These bright regions are most notably concentrated in Acator Crater, a 92-kilometer-wide impact site that hosts what appear to be domes and fractures, clues that point toward past or even current cryovolcanic activity. The central bright area, called Cerealia Facula, along with its companion regions, Venalia Faculae, has provided compelling evidence that briny liquids from beneath the surface have seeped up through cracks, sublimated in the vacuum of space, and left behind reflective minerals such as sodium carbonate. This discovery opened a floodgate of questions. Could subsurface oceans still exist beneath Ceres' crust? If so, might these briny reservoirs harbor the basic ingredients for life, or at least the potential conditions for life to exist? After all, on Earth, life thrives in some of the most extreme environments, including deep-sea hydrothermal vents that share some characteristics with Ceres' possible interior processes. As researchers analyze more data from the Dawn mission, they're beginning to unravel an increasingly complex picture of Ceres' evolution. Its surface appears to be young in some areas and ancient in others, marked by both fresh flows and heavily cratered terrain. This suggests that resurfacing events have occurred throughout its history, possibly driven by internal heat and liquid movement, phenomena typically associated with more massive celestial bodies like moons or icy planets. Moreover, gravitational data from Dawn helped scientists build models of Ceres' internal structure. These models support the theory that the dwarf planet has a differentiated interior, a rocky core, surrounded by a water-rich mantle and an icy crust. That layered structure is key because it resembles some of the solar system's ocean worlds, such as Europa and Enceladus, which are prime candidates in the search for extraterrestrial life. Ceres' relatively low density, combined with its abundance of volatiles, further supports the idea that it formed in the outer solar system and was later drawn inward. This journey could have allowed it to retain more of its icy components, making it a rare hybrid between asteroid and comet, part rock, part ice, and all mystery. Even though the Dawn mission officially ended in 2018 when the spacecraft ran out of fuel and went silent in orbit around Ceres, the data it collected continues to fuel research and inspire future missions. Scientists hope to one day return to Ceres with more advanced instruments, or perhaps even a lander that could drill into the surface and sample the subsurface brine directly. As we continue to study Ceres and similar objects in our solar system, we edge closer to answering some of humanity's most profound questions. Are we alone? How common is life in the universe? Could worlds vastly different from Earth still harbor the ingredients, or even the signs, of life? Ceres, once just a faint point of light in the sky, is now a beacon for exploration and discovery. With its glowing spots, icy secrets, and tantalizing hints of activity, it reminds us that even the smallest worlds can hold the biggest surprises. Salt deposits that reflect light and form mysterious bright spots on the surface of Ceres have captivated scientists. The most famous of these spots is located in the crater known as a crater, specifically at the location known as spot number 5. This region has attracted significant attention due to its high reflectivity and regular shifts observed by the Dawn spacecraft. These fluctuations are believed to be caused by water sublimation, suggesting that cryovolcanic activity might still be occurring, or may have happened recently, on Ceres. In addition to Spot 5, Ceres hosts other bright spots, each with its own distinctive characteristics. These spots aren't restricted to a single location but are spread across the surface of the dwarf planet. This suggests that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots emphasizes the active and dynamic nature of Ceres, challenging the previous belief that it was a geologically dormant world. As the Dawn spacecraft continued to send back more detailed images, it revealed a surface marked by a variety of craters, each telling a unique part of Ceres' history. The discovery of these features on Ceres has significantly changed how we view this dwarf planet. With its icy composition and signs of possible cryovolcanic activity, Ceres challenges many theories and expert opinions about new planetary bodies. No longer considered simply a frozen relic, it is now seen as an active and evolving world. The bright spots, particularly in the crater of a crater, continue to generate curiosity among scientists as potential glimpses into processes that go beyond simple geology and may even relate to the planet's capacity to harbor liquid water. The study of Ceres has far-reaching implications that go beyond understanding a single dwarf planet. By examining Ceres' internal composition, surface features, and chemical makeup, researchers can gain crucial insights into the broader dynamics of icy bodies in the solar system. Materials found on Ceres, such as water ice, ammonia, clays, and salt deposits, could offer valuable clues about the chemical composition and environmental conditions of similar celestial bodies, both in our solar system and beyond. Moreover, the potential for cryovolcanism on Ceres opens up intriguing possibilities about geological activity on icy moons and dwarf planets, not just within our solar system, but even on exoplanets. It suggests that environments we previously believed to be static or hostile might actually be dynamic and capable of supporting complex processes. Could this also mean that other distant worlds, once thought to be frozen and lifeless, could harbor conditions conducive to life? NASA's Dawn mission stands as a testament to the power of space exploration. The information it has returned has already reshaped our understanding of the solar system's formation and evolution. As we probe deeper into Ceres and other far-off celestial bodies, each new discovery brings us closer to understanding how planets, moons, and other objects evolve over time. For now, the bright spots on Ceres remain one of the most intriguing phenomena in our exploration of the cosmos, but they are only the beginning. As technology advances and more missions are launched, even greater revelations are likely. Ceres, once an obscure and forgotten dwarf planet in the asteroid belt, now stands as a beacon of potential and mystery. Its surface, internal structure, and enigmatic features may hold the key to understanding the origins of the solar system and the processes that led to the formation of planets and other bodies. The potential for life, or the ingredients for life, on Ceres remains a thrilling possibility that continues to motivate scientists and space enthusiasts alike. As we continue to investigate Ceres and other distant worlds, the line between science fiction and reality continues to blur. The idea of life on other worlds, once a topic of imagination and speculation, is now a real and important question. Could microbial life exist in the underground water pockets of Ceres? Could other icy moons in our solar system offer conditions suitable for life as we know it, or life we've yet to imagine? These are the questions that will drive the next wave of space exploration and may eventually unlock the mysteries of the universe. As we look to send more spacecraft, and possibly even humans, to explore these distant worlds, the discoveries of Dawn and future missions will continue to shape our understanding of what's possible in the universe. From Ceres' icy surface to its bright spots that may indicate the presence of liquid water, The dwarf planet stands as a reminder that there is still so much we don't know about our solar system and the wonders it contains. The objective to investigate Ceres is far from over, and with each new discovery, we come closer to uncovering the secrets of this fascinating world. Let me know what your thoughts are about the findings on Ceres in the comments below. If you found this video fascinating, don't forget to hit the like button and subscribe for more updates on the latest space missions and discoveries. As more data from the Dawn mission continues to arrive, scientists are only scratching the surface of what might be learned about Ceres. The bright spots, in particular, have sparked not only scientific curiosity but also public imagination. Their mystique raises more questions than answers, fueling ongoing research into the possibility of further geological, or even biological, activity. The fact that these spots are spread across the surface suggests a systemic process in operation and that something significant may be happening beneath the surface, potentially involving water or briny materials that could create an ideal environment for future exploration. While the Dawn spacecraft has already made great strides in unveiling the wonders of Ceres, there is still much left to discover. As technology progresses, we can anticipate even more in-depth images and measurements that will deepen our understanding of the world. Each image or piece of data sent back brings us one step closer to understanding the full story behind this mysterious icy dwarf planet.